In the section 1.8, we're going to solve real-world problems involving proportions. And if you can see in the first paragraph here, it says, to succeed on this TEAS task, you will need to understand not only what a proportion is, but how to set one up, solve it, and identify the rate of change, also known as the constant of proportionality. So the objectives for this section are, we're going to define a proportion, we're going to set up a proportion, we're going to solve a proportion, and we're going to identify a constant of proportionality. And the key terms is the constant of proportionality is the ratio between two quantities. A proportion is an equality of two ratios, and to solve is find the answer. So as we can look at some of these paragraphs here, we can see that a proportion is a ratio in fraction form set equal to one another in fraction form. So as we look at this example, if one ratio is 2/3, a scaled up ratio may be 4/6. And what you can see is that we just took 2 times 2 and got 4, and 3 times 2 and got 6. This would be the same way as if we were taking a fraction and making it a bigger fraction. We can also do the same thing on the 5/8 one. We can say 5 times 3 is 15, 8 times 3 is 24, and get another ratio. These ratios are equal, just like they would be a fraction. If you took 15/24 as a fraction and reduced it, you can reduce it down to 5/8. The same thing with the first one. If you took 4/6 and reduced it down to 2/3, you would just divide by 2. So even though you call this something a proportion, it works the same way as fractions. An example would be this. If 1 centimeter or 1 cm is equal to 50 miles, and we measure 12.6 cms or centimeters between two destinations, we want to know how far we would have to travel. So what we do is we would set up one side of our proportion as one fraction. We're going to put 50 miles over 1 centimeter, and we're going to have that equal to x miles over 12.6 centimeters. This is our proportion. It describes the situation that we've got here. And just like you would with a fraction, when you have one fraction equal to another fraction, and you're trying to find a missing numerator or denominator, we're going to use cross products. So we would take 50 times 12.6 and get 630. We would take 1 times x and get x. And so our final answer is 630 miles would be our distance. This kind of leads us to what we call direct proportion and the constant of proportionality. You have seen these two before, you just didn't know it, or you may not have recognized what it was. An example would be the slope-intercept form. Some of you may have had a graphing class where you know what this is. It's y equals mx plus b, where m is the slope of the line, b is the y-intercept point on that line, and the equation becomes y equals mx. We can see that here in an example. 0b is our y-intercept. Negative b divided by m over 0 is our x-intercept. So our slope or our line equation is y equals mx plus b. If we put b was 0, then we would just have y equals mx. Or our slope times some constant number, where the slope, which is the same thing as k, is our constant of proportionality. Another example might be if we had a number y equals x. And if we double x, then y is equal to 2x. So if we started out with x equal 1, y equals 2 times x would be 2. So y would be 2 while x is 1. This will be our slope. We're going to solve more of these proportionalities when we get to the next section. So right now I want you to go back and look at your practice problems. You will see that you have to set up 3 different proportions to solve for one particular unknown number in the examples. So go out and look at the practice problems that I've got worked up in Canvas, and hopefully you'll be able to understand this. But I do have one example that I'm going to show you now. Here's an example of setting up a proportion. We have the problem. It says George can drive 50 miles in 1 hour. So how far can he drive in 5.5 hours if he keeps the same rate of travel? In other words, 55 miles in 1 hour, how far can he drive in 5.5 hours? So we set up our proportion. I put 55 miles over 1 hour is equal to the number of miles he can drive in 5.5 hours. This looks exactly like a fraction, except it's got units of measure. And you will notice that when I set up my proportion, I made sure that the same unit of measure is on top on both sides, and the same unit of measure is on the bottom on both sides. You have to set up every proportion like this. Same unit of measure on top, same unit of measure on the bottom, or when you do the cross products to solve for the missing number, n, it will not work. So in my example, I took 55 times 5.5. I set that equal to 1 times n. I got 55 times 5.5 is 302.5. That's equal to 1n. So this looks like an algebra problem now. So 302.5 miles is equal to n. So he can drive 302.5 miles in 5.5 hours. And you can see from the examples that you have in your practice problems, this can be used to solve any type of problems, proportion problems, where you have one missing number. It would not make a difference which one of these four numbers is missing. As long as I had three of them, I could find the fourth one.